so now this topic is trigonometry and geometry. Uh, Now this is question 17 from paper 2022. So four circles of radius R1 are inscribed in a square of side 4R1 as shown in the diagram below. What is the radius R2 of the largest circle that can fit in the space at the center of the square bounded by the outer circles? Okay, so let's look at this question then. Creating a bit more space for myself. So the trick to this question is to draw a triangle like this, where this base here will be R1 because that is the radius of that large circle. This height here is equal to the radius because you can see it's sort of parallel to that, to the radius there. So that will also be R1. And this will be R1 plus R2 because it's both radii. So we can use Pythagoras' theorem here to relate the two. So part A, Pythagoras' theorem will tell us that R1 squared plus R1 squared will equal to R2 plus R1 squared. Okay, so that would tell us that 2R1 squared will equal to R2 squared. If we expand this out, double brackets, 2R2 R1 plus R1 squared. Okay, now we want R2, isn't it? So we can start to look at doing that. So this will give us 2R1 squared, which will equal to R2 plus R1 squared. And we want R2 on its own. So what we should do is square root both sides. So we'll get root 2 R1 will equal to root R2 plus R1. We want R2, so R2 will equal to root 2 R1 minus R1, which is root 2 minus 1 R1. That's it. Excellent. Okay, so now part B is a bit more interesting. It says that if 8 spheres of radius R1 are now similarly arranged inside a cube of edge length 4R1, what is the radius R3 of the largest sphere that can fit in the space of the center of the cube? So there's going to be, now we're interested in a diagonal, okay? So this time there is going to be a diagonal which will cut okay. Now this diagonal, now this is the diagonal of the cube. Okay. Now in Pythagoras' theorem for 3D, the diagonal of a cube will equal to a squared plus b squared plus c squared. So in this case, the diagonal will be 2 so the edge length is 4r, so that would be 4r1 squared times 3. So that will be the root 3 can come out, so that will be root 3 times by root 4r1 squared. So root squared cancels out, so that will just be root 3 4r1. Okay, so that's the full length of the diagonal. Now we can split up this into 4 parts, okay? Split up the diagonal into 4 parts. You can see 1, 2, 3, 4 parts, okay? That's clearly 4 parts. Now 1, 2, 3, 4. So just looking at this part here, you can choose to isolate that part there. So that means 1/4 of the length here will be of the diagonal, will definitely be R1 plus R3. Yeah. So 1/4 of the diagonal will be 1/4 of 4√3 R1, which will be √3 R1, which is going to be this length here, which is definitely R1, and this length here, which is R3. So it's going to equal to R1 plus R3. So this √3 R1 is going to equal to R1 plus √3. So R3 is going to equal to √3 minus 1 R1. Okay, interestingly. So you can see with 2 dimensions, it was √2 minus 1. 3 dimensions, √3 minus 1. Interesting outcome.